issues occur. The first would be to identify the issue, diagnose the issue, solve, and then prevent it from happening in the future. So this particular slide talks about the monitoring and optimizing performance capabilities of the various Optim tools that IBM offers. The Optim Performance Manager tool, for which we are talking today, is useful in identifying and diagnosing problems with respect to performance issues for your database. There's another product called the Optim Configuration Manager, which also helps you in some bits to identify and diagnose problems. And to solve the problems, you have the Data Studio product. And for SQL query tuning or workload tuning, we can use Optim Query Workload Tuner or Pure Query Runtime products. And DB2 has something called as WLM or Workload Manager, which can be set up to have various SLAs attached for different kinds of workload, so that any performance hits on very important workloads is not hit upon during regular business hours. So this is the ecospace in which the Optim Performance Manager tool works. So let's try to understand the architecture highlights of Optim Performance Manager and what it brings to the table. Starting with OPM 4.1 version, we have moved to a client-server architecture which has a web-based user interface. The current version of OPM is 5.2 and version 5.3 is releasing in a couple of weeks, along with DB2 Kepler. Optim Performance Manager does periodic data collection from the various monitor databases using in-memory metrics, event monitors, and snapshots to build historical repository of performance data. The collected data is stored in an internal DB2 table, database called the PerfDB or the repository database. And in the current versions of OPM, there is support for real-time viewing of performance data. The data that is collected by OPM is aggregated into 4 different levels. Out of the box, the default values for these various levels are 5 minutes for the aggregation level 1, 15 minutes for aggregation level 2, 1 hour for aggregation level 3, and a 1-day entry for aggregation level 4. What this means is, depending on how your monitor database has been set up to collect performance data, data would be collected every 5 minutes and an entry is made into the aggregation 1 tables. The least that we can go here is 1 minute interval, but the default value is 5 and the user can go and change it to a 1 minute interval. For aggregation level 2, data that has been collected over the last 15 minutes is aggregated into a single record and stored in the aggregation level 2 tables. Now this data, the historical data that is present in the aggregation tables, can be saved up to 2 years. That is, without performing any other settings, the data would be there in the performance repository for 2 years. So at any point of time, you can go back in history and verify what has happened to a database in terms of performance. OPM also comes with standard templates depending on the kind of environment that you have where your database is running. For business intelligence kind of setup, for OLTP, or if you have an application server that's running in your setup, we have templates which identify the key important metrics that would need to be collected in order to understand the performance issues for a database and how to prevent them. I'll move on to the next slide where we talk about the architecture of OPM and what are the different components of OPM that are available. OPM is divided into basically two different components. One is called the console server and the other is called the repository server. Now the repository server is the one which runs and picks up performance data from the various monitored databases. So the way data is collected would be based on in-memory using in-memory metrics or snapshot UDS or event monitors. And this mode is for databases which are DB2 versions 9.7 and above. For database versions below 9.7, that is 9.5 and 9.1, we use the snapshot UDS. Now the collected data, as I mentioned earlier, is saved in the performance repository database. And the console server provides the web interface that is used to configure anything that you have on OPM with respect to what databases have to be monitored, what metrics have to be collected, what is the time period for which you want the data to be collected, all that. And also the web console provides you with something called as dashboards and reports to view the performance metrics in a usable fashion. Starting with OPM 5.3, which is releasing in a couple of weeks, we have embedded a subset of OQT to help users analyze any issues with SQLs and find out what issues it could be using the Optim Query Workload Tuner. Of course, if the user has a full-fledged client of Optim Query Tuner, even that can be used along with OPM to directly move from, view the SQL on OPM and move it directly to OQT and perform any analysis and tuning as well. So apart from these basic features, there is an additional component called the Extended Insight Client or EI license that can also be taken along with OPM. And this helps in analyzing not just the database issues, but also where different times are being spent over the entire stack of your application, network, operating system, the driver level, and other layers. Later on in the session, we'll show you the drawing and the dashboard, which shows details on what metrics Extended Insight brings into picture. So that's the architecture, basic components of OPM that a user would see. Moving on, the first dashboard that I'll touch upon is called the Health Summary Dashboard. Now, this is probably the first place that users might use to identify any issues for their various databases that are being monitored. So you will see various kinds of alerts that are thrown on this particular dashboard and very easily identifiable in terms of red alerts or the yellow alerts where particular SLAs are being crossed. And whenever there are any alerts that are there, we can also set up notifications to be sent to the administrators or anyone else so that they can take necessary actions to mitigate that. So we can set up email IDs on OPM for alert notifications to be sent. Apart from this, once we identify a particular alert for a database in the various sections that are shown here, we can drill down further into identifying what exactly is the alert for and what action needs to be performed for that particular alert. So on the current screen that is being shown, we can see that there are some alert details that are being shown and there are actions that are recommended. And the action that's recommended in this particular case is to move to something called the locking dashboard, because the alert that we have selected was a locked alert. And once we go to the locking dashboard, we can see complete details about that particular lock, at what time it occurred, what applications or what sequels were running which went into the log, and various other details. And once we drill down into that particular lock, on the locking dashboard, you also have the facility to force the stopping of the application or the SQL itself in case it is currently running still on the database. Even from the locking dashboard, we can launch Optim Query Tuner to tune the query for any performance issues that are noticed.